Is the revision. I'm going to the same video which I had sent. I will mention which video it is. As I had said in that video, it was not seen because the font was a bit small. And before I start this video, I would just try to tell you, in the previous maths video, at times the paper must have come out of the frame and there are 1-2 numbers which are missing, and I was just going through it, like it can be understood later, which that means you can know that number is missing, but still I'll be repeating that video again, so please make a note of it. Okay, now we start with this. Convert the following temperature to Celsius scale. Now look at this question. Convert the following temperature to Celsius. So when the question comes Celsius, they'll give you Kelvin. I repeat, convert the following temperature to Celsius. So children, you all should know how we have meter to centimeter. Okay, 1 meter is 100 centimeter. Okay, and then you want to convert centimeter to meter, like you have to divide, no? You have to divide by 100. Same way in science we have conversion scales. So if it is Kelvin, just by heart that to get Celsius you have to minus. Very important. What you have to do? You have to minus. So I repeat, learn with me. Kelvin to Celsius, so you have to convert to Celsius. So whatever value is given, you have to take that value and minus. Now 300 minus 273, okay, is 27 degree Celsius. Now this 273 has come down here. I will explain to you. Okay, so it's understood. Okay, now concentrate on this sum. 300 minus 273 is what? 27 degrees Celsius. So what is the answer? Answer is 27. Now next is 573. 573 minus 273, which is equal to 300. Now you can keep degrees Celsius out. What happened here? This 273 went here. So what we'll do? Let's cancel him. So when you're taking the PDF, this 273 had to come here, and then when you type, no, because this thing was typed, so before taking the printout, it must have just gone down to the next line. It had to come over here. So 573 minus 273. So I have to minus 273 to get conversion. Now the reverse is with Kelvin. Now here Celsius to Kelvin, and this is Kelvin to Celsius. Now if you have to convert Celsius, this by heart, you know what you have to do? Just by heart one. The other one is the opposite. So by heart like this. Okay, Kelvin is given and you have to convert to Celsius. Kelvin is given, Kelvin is bigger, so you have to minus to get Celsius. And if Celsius is given and you have to convert to Kelvin, then you have to add. So you by heart one, the other one is the opposite. Okay, so now Celsius is small. Learn that way. To how to get Kelvin, you have to add. So what we did here, see, we added. See, again this one went here. Okay, so we have to put 273 here. Okay, and then we get this. So don't forget, here we have to add, and here we have to, okay, don't forget that. Put one nice. You have to keep like this hints for you to remember. Okay, so here we are adding. So we got 646. Is this clear? So this is a small, so I'll just do it on a paper. 300 K. So convert to, now what is given? We have to convert to Celsius. This being 1, I'm solving. And then if I give 250K, example, other than those two examples, and we have to convert to Celsius. What we have to convert to? Celsius. Okay. So Kelvin is given. So what to do? 250. Kelvin is bigger. So to get Celsius, you have to, okay, minus. And then I'll change this to 290. Yeah, we'll make it bigger. Then simply the other type will come that we have to get minus sign. So 290 is given. So 290 minus 273. How much? Let us see. It's 17. Now it's no longer Kelvin. This 1, 2 examples are enough. You don't need 100 examples. And the second one is convert to Kelvin. We'll take another example. 30. Okay. So now I want to convert to Kelvin. So 30 plus 273. $330. You have to write, if you don't write this, they cut marks. And remember, to get Kelvin, you have to add. Okay, Celsius. And if Kelvin is given and you have to get Celsius, you have to minus. So Celsius is smaller. So if you have to get Kelvin, we have to add. So other one is minus. Is that clear? So this was a simple institution. Very little slow because sometimes you have to understand exactly what's happening. Now give reasons. Now let me be precise. Whatever examples I've solved, these examples have to be done in the notebook. These examples have to be done in the notebook. Okay, listen to what I'm saying. I don't have to again send a message. So whatever I'm saying, sometimes pay a note and write a note there. I have to write in the notebook. Give reasons for the following. Now, today we are doing just a few examples. I mean to say reasons. And the next 2 videos will be, as I told you, on examples, more reasons, more give reasons. And then I'll just be taking the textbook just to see if we have, just to get some, all figures I cannot keep on drawing. So why to waste time? So I'll be explaining from the textbook. I'll be making you to draw those on the notebook. Is that clear? Now, when we do give reasons, very important is you have to understand what is happening. Now, for example, let us take the first give reason. Let us do fast. Naphthalene balls disappear with time without leaving any solid. So everybody knows about naphthalene balls. We put in the bathrooms, okay, so that to drive away insects. Now, the question is, it disappears. Now, children, I am going to give you quite number of give reasons. But sometimes it is not necessary the give reason will be the same what comes. So you have to know what exactly they want in that. So by going through the number of give reasons, you will understand how to tackle other give reasons. Now they are saying naphthalene not disappear. Okay, so means there is no solid. So what it is becoming, if disappears means sure shot, it is turning to vapor. It is not becoming liquid. Anytime you saw naphthalene becoming liquid, no. So you have to know the property. It becomes vapor. So it becomes vapor means it becomes gas. So what is the answer? Naphthalene balls disappear with time without leaving any solid because they undergo sublimation. Very, very important. What is sublimation? It is a process in which what? A solid gets converted directly to gas. Gas is also vapor. Solid gets converted directly to vapor without going through liquid state. If you don't write that, they cut marks. So solid to vapor, I was trying to tell you, these are sublimation, but without going through liquid state. So solid gets converted to vapor, that is gaseous, or gas gets converted to solid. So it can be vice versa, means reverse. So gas can be converted to solid is also sublimation. Is that clear? Gas getting converted to solid, or solid getting converted to gas. Okay, sublimation. They are called sublimable substances. That is directly changed to vapor without passing through liquids. Now in the give reason, you don't have to write big version, but you have to write the give main reason. Why we didn't go to school? Because I'm getting a headache. No, I got up late and all that. Should you give that reason? No. Why you didn't finish your videos? Teacher, I don't have Wi-Fi problem. I don't have this. So that is the thing which you have to give. So when you say give reason, you have to know exactly the reason has to be in connection with what the question is asked. We can get the smell of perfume sitting several meters away. Children, now you all are a little bit, I know now there will be too much work at home. Take a perfume, and if you spray a perfume, you will see that the smell can reach several meters away. Now, the previous give reason was based on sublimation. This give reason, who can tell me, is based on what? Why we are getting the smell far away? Because something is spreading. So, I am coming to a point. When any give reason is asked, you have to ask yourself, this question is based on what? What point? Means what is the main concept? Means someone is moving. So we know that when we spray perfume, it is actually particles of air, right? In air, means it is in the vapor state. It's air. So guess. So in other words, let me be short. Ask yourself which state it is. Which state? When I spray a perfume, okay, can we see that particles? No. So it is in solid, liquid. Liquid, no, because liquid is a flowing liquid, it's a fluid. It takes the shape of the container. We can see it. Solid has a fixed shape, definite shape, fixed boundaries, distinct boundaries. I'm just revising the characteristics. But gases do have no shape, no volume. Okay, so the particles of perfume are in the gaseous state. It's a gas. So what are the characteristics of gases? Now see, and one more thing. Particles mix. So something of mixing and spreading. So, and we know, so should we use the property that particles have more space and then it's easy to compress? No, we are not talking about like whether we have to compress it or not. We are talking about why we are getting the smell. Means something is spreading and mixing. So we have to say the particles mix on their own with the particles of air. So children, remember, particles of air also is there. So the particles of perfume mixes with the particles of air and spread out, and is spread. Okay, how we spread the disease, COVID, like that. Due to the spreading, we can get the smell. So you cannot say that I have more space here, then here you will get less marks. Because here this is something of spreading. Now, we had learned diffusion, which I am giving you into the definitions. It will come. It is say after me, intermixing. This property is based on diffusion. Intermixing of particles of two types of matter on their own. Say after me, intermixing of particles of two different types of matter on their own only they will. Now you take salt and put in water. Can you see salt separate and water separate? No. The particles of the salt mix with the particles of water on their own, and we get salt solution. So this is called diffusion. Okay, so diffusion is a definition, but it is used in like this, what are these called? Situations. Now, arrange the following substance increasing order of the following attraction between the particles, water, sugar and oxygen. Now, we know water is a liquid, sugar is a solid, oxygen is a gas. So the intermolecular force, very important, we have to talk about intermolecular. To by hand this. Intermolecular force of attraction is least. Least means less, not that least. That least is LIST. Followed by liquid, maximum in solids. Okay, so the force of attraction, children, is more in solid. Strong force of attraction in solids. Because they are closely packed. Solids. Okay, negligible. What's another word for least? Negligible. What's another word for least in gas? Negligible. Negligible means small. Okay, liquid is intermediate. Therefore, it is least in oxygen, followed by water, and maximum in sugar. Let's put an E in here. So, intermediate. Okay. You can say intermediate in water. Nothing happens. It's the same thing. Okay. So, solid is maximum, least in oxygen. Now, what is the physical state of water? I've done this in a video. When it is liquid, 25 degrees Celsius liquid, children, because 25 degrees Celsius room temperature. And listen to me carefully. 25 degrees Celsius is room temperature. Room temperature, which state water means the liquid, because it takes the shape of, at that temperature, why it is liquid? Because it takes the shape of the container. It is flowing. That's why it's called fluid. It is not rigid. So that temperature, water takes the shape of the container. So it's a liquid. So liquid, it is a liquid because we can see it flowing. The very important point, it takes the shape of the container in which it is poured. It is flowing, so it is called a fluid. It is not rigid. Rigid means strong. Is that clear? That's why it is a liquid at 25 degrees Celsius, which is room temperature. I repeat, 25 degrees Celsius is actually which state? Liquid. Even this comes reason because at this temperature, it is a room temperature in which it takes the shape of the container in which it is poured. It is flowing. Hence, it is called a fluid. It is not rigid. Okay. 0 degrees Celsius is a solid. It is also a freezing temperature. Say after me. It is a freezing temperature of water. I have explained 0 degrees Celsius applies for solid state also, and it applies for freezing temperature of water. What is freezing? Water is becoming ice. Say after me. Water, I want to make ice. We boil the water and we put it in the freeze. That is freezing. That is also 0 degrees Celsius. Okay, so if they ask you what is the freezing temperature of water, say 0 degrees Celsius. 0 degrees Celsius is solid also. So now children, I fill my ice tray and I put in the freeze to become solid. So liquid is becoming solid. Now we have learned liquid getting converted to solid is solidification. Say after me, liquid becoming solid is solidification. So when water is freezing to ice, it is becoming a solid. So solidification. I repeat. The freezing temperature of water is 0 degrees Celsius. So when that water is becoming solid, means water is freezing to solid. In other words, liquid is becoming solid. So when liquid is becoming solid, it's called solidification. And ulta, solid getting converted to liquid is fusion. So when it is melting, that is fusion. Solid melting to liquid. Now, I have repeated this many times and you all should know by now. 100 degrees Celsius. Now, in 100 degrees Celsius, I told you when it's boiling, will reach a point where liquid is no longer liquid now. It has become vapor. That's called the boiling point of what? Boiling point. What's the boiling temperature? 100 degrees Celsius. So, it's the point at which the liquid is becoming, means it boils. If I ask what is boiling point, you should know what is asked. Liquid is boiling. Liquid boils. Okay? At atmospheric pressure. Liquid is boiling. But when the process in which the liquid getting converted to vapor, it's very important, so I am repeating it. Any temperature, okay, at atmospheric pressure, that is evaporation. Liquid getting converted to vapor, liquid getting converted to vapor. But what is that point, that boiling temperature is 100 degrees Celsius. I repeat. Now, boiling point is the temperature at which the liquid boils. So it is that point. Okay. So what is evaporation then? It's a process in which the liquid gets converted to vapor at any temperature. That's very important, at atmospheric pressure. But after it passes 100 degrees Celsius, it is no longer liquid. It becomes vapor. So if they ask you what is the boiling temperature of water, you have to say 100. Okay. Water at room temperature is liquid. This is what I have explained. Water at room temperature is liquid because it does not have a fixed shape. All characteristics of liquid you have to put here. It takes the shape of the container. It flows easily. Hence, it is not rigid but a fluid. It's the same thing what I have explained. Is that clear? So, what you have to put here? Characteristics. Characteristics of what? Characteristics of what? Liquid. Next, a solid. An iron is a solid. Now, an iron, a cupboard, whatever, it means at room temperature. At room temperature, they are solids. Why? Why they are solids? Because an iron almirah is a solid because it has definite shape. So, a question is, they are trying to ask you a question on why it's a solid. So, you have to talk about characteristics of solid. So, that's why I asked to give reason. You have to see what the question is. So, you have to talk about characteristic of solid is it has definite shape, it has a fixed volume. You can talk about distinct boundaries. It does not flow, hence it is rigid. In liquid, it flows, it is not rigid. Okay, so you have to be a little bit also, it should be to the point. It does not flow, so strong, rigid. Okay, is this clear? Now these two are very important, very important. So put there very important and understand. If you have not understood, put across. I'll explain again. But children, don't wait for me to. You all are not small children now for your parents to feed you. Neither are you small for the teacher to feed you. Okay, understand. Try to use your brain. Exactly what's happening. See, I will just hold your hand and help you to understand. You all have to take the trouble to see exactly. Use your mind. This is happening. Okay, and try to think of different things. Okay. Now, why ice at 273 Kelvin is more effective in cooling than water at same temperature? Now, don't forget 273 Kelvin. Let's write here. 273 Kelvin. If I convert to Celsius, is 273 minus 273. Yeah, no, which we get 0. So I have converted now. You saw this?